me start. All right, so welcome again to the IBPSA Mixa event. I have all of your slides in a slide deck, and if I don't, if you want to present an idea afterward, we do have time for that. So I'll open the floor to that when it's time. All right, so this is how, so everyone can still see my screen, or am I sharing the wrong one? Let me see.
We can see it.
You can see it. Okay, awesome.
Yeah,
Great.
I'm seeing
No.
presenter
Oh,
view.
okay, you're seeing presenter mode. Let me switch that. Great. So everyone see the big slide? Awesome.
Yep.
Great.
Yes.
All right, so this is how, so first of all, welcome, and thank you for signing up and also submitting your slides. We did have over 20 people say they wanted to pitch, but only 10 were able to submit the slides, which is totally fine. I know people get busy, they get excited, and then they get busy. But hopefully this excites you for SimBuild coming up. There are also pitch sessions at the conference that you can sign up for. I think they might be shorter than 60 seconds, so this is like a cakewalk for you all if you have to fit it into 30 seconds. So be sure to sign up for that. I know that in 2024, I pitched my sessions at those like pre-breakfast opportunities, and it really drummed up a lot of interest for the session. All right, so today we are going to have 10 speakers. Like I said, the order of the speakers will be on the next slide, and I'll pause there for sure to let you all kind of get where you are in the lineup. Slides will advance after 60 seconds. Some people submitted the Canva template, which had more than one slide. So those will advance in like 8 to 10 second kind of intervals, depending on how many slides were included. And then there will be a 5-second transition in between. So you'll see your name pop up saying you're the next speaker. And then you're all free to unmute yourself and start speaking. After the completion of the pitches, we'll have an open Q&A for the speakers, as well as anyone online who didn't get the opportunity to send me their slides in time, or even have just a new idea they want to talk about. We'll talk about that. And then with time permitting, I'd love to just talk about the conference itself. If there's any first timers that want to raise their hand and tell us why you signed up. If there's any veterans here that wants to share some tips about how to get the most out of the conference, I'd love to do that exchange as well. All right, and then we'll probably just highlight as well some of the social events, tours, and other things that you might be interested. All right, so before we begin, is there any questions? All right, great. All right, so these are the 10 speakers. So you can find your name, find your title. If you are not on this list and you want to present, I will invite you to present after the 10 people who provided slides beforehand finish. All right, so with that, I'm going to click to the next slide. And then, Andrew, you'll have 5 seconds to just prepare yourself, and then your slides will go, and then you're up. All right, well, thanks again for joining today's webinar, today's mix-up, and I hope you have a great time. All right, here we go. Oh, sorry, I clicked off of it.
Yeah, I'm not seeing the slide.
All right, I will click it. I'll click it since
Okay.
you're ready. Okay.
Okay. All right. Yes, thank you. So my presentation will be titled Automated HVAC Design and Duct Routing for Multifamily Retrofits Using Reality Capture Data. This presentation sets out to answer a fundamental question, which is, can we go from reality capture point cloud data to a full residential HVAC design essentially in one click using new algorithms, machine learning, etc. The need for that is that developing a complete HVAC design is a very labor-intensive process and a bit of a barrier to conducting these types of retrofits. So we'll be exploring using AI for classification, geometry simplification, computer vision for mechanical equipment layout, and then duct routing using algorithms inspired by printed circuit board and video game types of applications. So I encourage you to come see and see how it works out.
So much, Andrew. All right, I will go to the next one. All right, and I will highlight.
Yes.
I will highlight block.
All right. Thank you.
All
Yeah, I
right,
think.
ready?
Yep, I'm ready.
Okay, I'll click next.
Yeah. Hi. So oh yeah, and can you hit the play video?
Oh, yes. Thank
Yes.
you.
Hi. So my presentation co-authored with Remy here, also showing on the panel, would be about our tool climate twin, kind of like this tool coming out of our practice in where we see the need to understand the spatial environment in the urban world that we are living. So in this two side right here, you can see although they are just a block away in New York, but the feel like experience is drastically different, and that's why we want to dive into understand this characteristic and why this what caused that characteristic, and eventually build this the experience that we learn while working on this tool to influence our future practice at KBF. I'm not sure why it's not advancing.
Okay. All right, it should be advancing now.
Okay, yes. So introducing Climate Twin. This is our web app that like is accessed to everyone on different devices. It takes a daily forecast at the end of the day to pre-compute 24 hours interval, um, calculating CFD, radiation, MRT, and using UCCI as a metric to display thermal comfort. Um, I think there's a few more, but probably something wrong with the video.
Yeah, probably just internet lag. Hold on, let me see. Okay,
Yeah.
should be going now.
Yeah, I guess we can just click through it a little bit.
This
Yeah.
one?
Yes, and so after we build the app, we also conducting different validation through on-site measurement, since we are just a block away from the app, and validate it against a other peer review software, in this case NVMe. And we can see that there's a slight difference between different component of that go into the UCSI calculation, but overall, I think our models uh, have um, make a intentional trade-off for speed, however, without a sacrifice on the accuracy. So please come check out our presentation in SimBuild.
Thank you so much. Yeah,
Yeah,
sorry about the
thank you.
technical difficulties.
That's fine.
All right, let me click on to. All right, let me find you.
Hello.
All right, there you are.
All right. You guys can hear me okay?
Yes, we can hear you.
Great.
Okay, if you're ready, I'll click next.
Sounds good.
All right.
Hi, so I'm Ryan. I'm a third-year PhD student at Columbia University in the Building Energy Research Lab, and we recently did a working group with commercial real estate owners in New York City, and they identified construction drawing workflows as a key use case for Gen AI integration and automation, as it's very time-consuming and repetitive. So we set out to test how well current approaches can understand and ingest these construction drawings, and how custom approaches might be able to ingest these drawings. So we tested 4 workflows on 15 benchmark questions across 3 drawing sets, and found essentially that visual grounding substantially improves LMM-based construction drawing interpretation, but spatial reasoning remains a weak point. This is work in progress, so I'm just doing a lightning talk, but we are working towards sort of a benchmark eventually, maybe. We're going to see how that goes. So come see our full talk, or we have these prototypes available on our lab website if you want to check them out there.
Thank you so much. Let's see. Oh, hi, Young. You're welcome to pitch without slides as well. I'll call you up at the end. All right, thanks so much. Let me go to the next slide and find Jennifer.
Hey, can you all hear me?
Yes, we can hear you.
Okay, perfect.
All right, so I will press next whenever you're ready.
Yep.
Okay.
Okay, so in Los Angeles, the vast majority of people live in buildings that predate the year 2000. And when we look specifically at multifamily housing, one of the most prevalent apartment typologies are these stucco box low-rise structures that you see in the bottom right here. There's actually a vernacular term for them. They're called dingbat apartments. And today there's thousands of these like scattered throughout the city. And as much as people love to hate them, they're actually like a vital part of LA's ecosystem because these are naturally occurring affordable housing that people really hold on dearly as an option for affordable housing. And in Los Angeles, it's really common knowledge that these buildings were never designed with human comfort in mind, and they're commonly known to behave like ovens on hot days. So when we think about climate change and how our city is now experiencing hotter and more frequent heat waves, these buildings are now becoming extremely dangerous indoor environments. Um, and because Los Angeles is so rent burdened, there is a lot of back and forth of, is it ethical to just stick AC units in these units when you consider that a lot of people really struggle with housing payments in the first place? So in this study and in this presentation, we wanted to explore the question of, is it possible to actually retrofit these buildings using only passive cooling so that safe indoor temperatures can be maintained during an actual heat wave without mechanical cooling at all? So to do this, we set up a prototype model that you see in these images and measured indoor temperatures in each unit to, see what various passive cooling strategies, work. Did we achieve safe indoor temperatures? Well, we will present the findings at the conference and you'll find out. The results are pretty fun. I think you're on mute.
Sorry, I was saying someone put in the chat that they lived in one of these apartments and they can confirm the oven effect.
Yep, absolutely.
Thank you so much. All right, let's bring up the next one. So I will highlight Andy. All right, Andy, whenever you're ready.
Yeah, go ahead.
All right.
All right, so this is not a single talk, it's an entire session that Kate Bomar and I are running. You might know her from Project Stasio. We called it Where's My Visualization? It's friendly roasting. We're not looking to like get to the level of char. But basically, it's going to be a few demo roasts in front of the whole group, mostly for visualizations that we are bringing. And then we move into smaller groups for discussions of visualizations for people who maybe don't want to have a large group discussion about theirs. But yeah, basically, it's a very interactive way of learning what to do and not do with your graphics. And if you're feeling brave, we have a submission link. It's a Google form. You can select whether you want to be anonymous. You can select whether you feel comfortable with a large group discussion or if you just want it to be used for small groups. Um, but yeah, hopefully we get some submissions because we can't run this in a vacuum.
All right. Well, thank you so much, Andy. All right. All right. So, Jihoon, I'm going to spotlight you.
All right. Thank
Okay.
you.
All right. I'm going to advance to your next slide.
Hi, my name is Jihoon. I'm a postdoc from Oak Ridge Lab, and my topic is the bridging the gap between the smart building devices and accessible energy management software of targeting small and medium-sized commercial buildings. Next slide. Yeah, main issue is that there's this part of this segment of the commercial building is overlooked. So it consists of the 94% of the American commercial building, but it consumes lots of energy. So we analyze the existing software solutions, but generally they has this very limited ecosystem or very costly or is built for the residential buildings. So our approach is to use the YAML-based configuration file so that user write the the configuration, and then convert it into the system specific configuration, and then integrate the Fortran, which is the scalable backbone, so middleware software. Yeah, I'll walk you through more in detail in the next week. Thank you.
All right, thank you so much, Jihoon. Sorry if your timing was off. Something is something is silly.
Sorry about that.
Yeah. All right, thank you. Well, we'll have time to circle back on everybody's presentation, so that's a good thing. All right, so let me get Yella on Spotlight.
Hello, everyone.
Hello. You can go ahead whenever you're ready.
Yeah, I am. Hi, everyone. I'm here to pitch both a presentation and a pre-conference workshop. So on the 19th, we have a workshop, and on the 21st, we have a presentation. In the presentation, we want to point out the impact of thermal bridges on facades. So we will discuss, based on two real world examples, how point thermal bridging can dramatically increase the U value and overall heat loss of facade systems. So in this example here, this is one of the examples that we will discuss, which is a real project in execution here in Belgium. You can see the brackets in this facade that will penetrate insulation through the system, and it will increase increase thermal heat loss through this system. I think it goes a little bit slower than I thought. I have more time to speak.
All right, there you go.
So yeah, as you can see here on this 3D image, you can see that the overall U value of this facade is increased with 64% by taking into account these anchors and connections through the insulation layer. But of course, if we all want to calculate very accurate, but this of course comes with a cost of long simulation time, and that's why we also want to discuss in this presentation a new meshing strategy, which is the result of a 3 years research project at Visibel, where we combine an adaptive raster refinement with a hybrid meshing technique to reduce the simulation time for these type of constructions with about factor 10. So okay.
All right. Sometimes the internet wants to go slow, and sometimes
it was a little bit like unevenly distributed the time over the different slides.
I agree. Yeah, this will be better live in the conference. I promise.
Okay.
All right, I'm gonna highlight Miguel, and Miguel, I'll let you have more time because we already landed on your slide deck there. All right, so go ahead, Miguel.
No, you're fine. All good. Thank you. Hi, everyone. My name is Miguel from Lake Fatal Architects. I'll be presenting alongside Director of Design Technology Dan Stein at SimBuild for 2026 for our session, Advancing Sustainable Architecture, Data-Driven Tools to Design, Simulate, and Succeed. This presentation really explores how we're using tools like Autodesk Forma, Grasshopper, and Ladybug to benchmark environmental analysis workflows, validate design assumptions, and create compelling graphics and simulations that support better decision making early in the design process. We'll be discussing how these tools are helping bridge the gap between fast-paced conceptual designs and more advanced environmental analysis, including outdoor thermal comfort and CFD-informed studies, particularly in hot, humid southern climates where shading, walkability, and occupant comfort are critical design challenges. Through real-world case studies, including the strategies that supported WELL Platinum certification in our very own office, and help win high-performance projects, we'll demonstrate how data-driven workflows are shaping the future of sustainable architecture. So please join us on May 21st from 11:30 a.m. to 12:30 p.m. in the Great Lakes Ballroom at SimBuild 2026, and we look forward to seeing you there.
So much. All right, so let's see. I usually wanted to present later with a different slide deck, so we're going to skip over this one and go to, so let's see, Kimon, are you ready?
Yes, I am.
All right, great.
I don't see the slides. Do you guys see them?
I see, let me go back. Do you see the one with your name on it?
I don't see it on screen, but maybe it's my screen. Go ahead. If you guys see it, it's fine.
Okay. Does everybody else see it? Okay, so Ryan says he sees it. It's like the black slide with
Yeah,
the
yeah.
color
Yeah,
text.
okay.
Okay.
One slide. Yeah, great.
All right.
Yeah. Hello, everybody. Our session is called You Don't Design Net Zero, You Operate It. And it's a living building case study from PA who won all kinds of awards for their building in Portland. Advanced architects and engineers, amazing BIM, no data for operations. Last year, we helped them shift that into RDF knowledge graphs with ASHRAE 223P. We had a breakthrough about 4 months ago. We created a semantic bridge application that bridges from BIM in real time to semantic models, so you can simulate different things, see how the sensors are doing, update the model as it changes, as you're going to operations, new equipment comes in. And 2 weeks ago, we ran a simulation with a building. That's why you see the fire here. If you're running a building to make it comfortable for occupants with temperature and sensors and everything, the same data can be used for emergency response, but it has to be accessible. If it's not accessible, then it's in another silo. So this session's all about breaking silos with open source, open standards, live data, live interaction, and we invite you to join to find out more about it.
All right. Thank you so much. All right, so that actually concludes the pre-uploaded slides for today. And so I'd like to invite Ayush, are you ready? I see that you emailed me something, but if you just want to present from your computer, that'd be great. Now I'll remove the spotlight off of.
Let me know if you can see my screen.
Yes, we can see it.
Okay. Yeah, it'll take a minute and I'll start. Yeah, hi, my name is Ayush, work for Cyclone Energy Group, and the topic that I'm going to discuss is a case study where we actually figured out what HVAC option would be suitable for a historic building. Building is pretty much in New York, so it's a cold climate zone, and the other good part is it's an historic building, so envelope and everything has to be restored. That was a major challenge part. My mostly presentation is about like talking about the HVAC part of it being the critical one and the case we had to run on. The three HVAC options that we have explored was air to water heat pumps, ground source heat pumps, and VRF with heat recovery, and how the results had been varied has been discussed using IES. So we had input all those data in IES and did like energy model, and to know like what's the most suitable option amongst three, you'll find at the presentation. Okay, thank you.
So much. Young, would you like to do your pitch?
Yeah, sure. Thanks, Lisa. Okay, so, yeah, sorry, I didn't prepare any slides, so just like 1 minute is, so my name is Yang. Nice to meet everybody. I'm from the California Energy Commission. And what we'll be talking about on Friday morning in the state track is about kind of translation the gap between energy models and what actually get built. I mean, as many of you know, there's an enormous amount of data and input that go into energy modeling. And the challenge is, how much of the compliance information consistently get translated across the different stakeholder, including non-technical audience throughout the permitting process. So by the time that, the models move into plans, into compliant forms, installation, verification, inspection, all the way to the certificate occupancy, information are kind of transformed into so many different forms. Things change, sometimes they get simplified, interpreted differently, or, not like lost entirely. So our task is figuring out, on average across California, across different building segment, what are the actual compliance outcome from design to what get built. And we need to do this efficiently because there's limited funds and figuring out how to do this at scale. So ultimately, we want to identify like the top priorities that would meaningfully improve compliance. And we need a broader view of what happens, very quickly across many different project types, et cetera, for like the largest state in America. So we had some initial thoughts of how we're going to go about the evaluation approach, which is what we will present. And love to hear your feedback. So so that's
Much appreciate it. Let's see. Malihe, would you like to come up and pitch your idea? And you're welcome to share slides if you have them.
Of course, of course. Thank you.
If you just want to make it bigger, we can.
Yeah.
Awesome. Great.
Okay. Hi everyone. My name is Malihe, a PhD student at University of Vermont. And my paper is about open source Modelica models for designing multi-energy systems. Energy Hub is a platform that integrates and optimizes different energy sources such as sun, grid, and also energy types like electricity and heat and cooling and infrastructure like generating, storage, utilizing, or like exporting it. And when it integrates with district energy systems, it requires nonlinear dynamic models that most of the models tools does not consider that. They just use a simplified models. And the other gap is lack of performance metrics beyond electricity, such as self-sufficiency and self-consumption ratios. We have designed 5 models, and this is all the results. We have run it for more than 20,000 simulation for a case study. I will hopefully see you there and explain more about my research and my paper. Thank you.
Thank you so much. All right, so that is it for the planned presentation. So I'd love to open it up for anybody who has questions for any of the speakers before we move into a more free discussion on other topics.
I have a question for Young. Are you still there, Young?
Yes, I'm
Yeah.
here. Yep.
Yeah. Sounds very interesting what you just described. One part that I wasn't able to show in my quick 1 minute is that we have 5,000 buildings in California in the system that I just described. Every single community college building in the right location with the right envelope and everything. It'd be interesting to explore how that works. And there's a lot of different groups involved with that. Everything that we talk about too is about collaboration and open source, open connectivity to solve this complex problem of energy in buildings and the environment.
That's awesome. I'd love to get connected and chat more about that. Sounds like a perfect, sample of the and part of our study.
Mm-hmm.
I have a question for Clock. Is that right?
Yes.
Hey, seems like our presentations sort of are gonna overlap, which it's interesting to hear how you're doing your analysis and using Envy. But also I saw that you have a tool which is amazing because I personally developed my own